Hello, mathematicians. So this is our last regular lesson, and we're going to do it in three parts for this first unit. And so we're going to start out today looking at symmetry as we discussed yesterday. Yesterday we said that in order to more quickly graph functions, we could analyze the characteristics of the functions to produce a graph more quickly than just building a really super long t-chart. So we said their intercepts would be the first characteristic that we would explore. Symmetry is the second characteristic. So if I were you, I would pause the video and I would jot down these graphs in your notes. These graphs demonstrate a type of symmetry. Pause if you need to. Okay, the type of symmetry that each of these graphs demonstrates is symmetry with respect to the y-axis. Now, WRT means with respect to, and it is a math abbreviation that every mathematician would recognize. So it's not a Porterism, it's an actual abbreviation. So definitely you can use it. So symmetry with respect to the y-axis. Now, I want to tell you a couple more things about these so that you'll get used to how to look at them. So symmetry with respect to the y-axis means that you could fold the graph on the y-axis and then the two halves would overlap each other, right? If you held it up to the light, that they would be a perfect match. So if I were to pick this point and this point, these 2 points are mirror images of each other across the y-axis. Well, this point is positive 2, negative 2, and this point is negative 2, negative 2. So in a similar way, on the graph at the bottom, I could say that this point is a mirror image to that point with respect to the y-axis. Well, the point, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. So this is negative 8, 4. And this point would be positive 8, 4. Now, the graph on the upper right, again, we could pick this point and this point. So I'm going to count and say 1, 2, 3, 4, 5, 6. So this point's negative 6, negative 2. And this point's positive 6, positive 2. So could you complete my sentence? If xy is on the graph, then blank is on the graph. So any graph that shows symmetry with respect to the y-axis has to have what other point on the graph. So if you said negative xy, you are correct. So however far you go right and up, you should go left and up that much. Or if you go to the right and down, you should go left and down that much. That's what that's saying. Now, let me mention that if these graphs are functions, because you could build symmetry with respect to the y-axis and not have a function, but if these graphs are functions, so if the graphs pass the vertical line test, the functions are called even functions. And the abbreviation for function is just FN. So again, that's a mathematical abbreviation that people would recognize, and I use abbreviations all the time. By the way, how much do you know about these graphs? So do you recognize that this one is an absolute value function because it forms a V shape? Now this one you wouldn't necessarily know, but it's a trig function. Trig functions are cyclical. They're repetitive. So you get a wave pattern where all the waves are equally tall and equally wide, and it just repeats itself over and over and over again. Now on this last graph, it's got the dark green lines are supposed to be vertical asymptotes. So when you have a graph that's in pieces like that, it's a rational function. So we're going to work on, especially next chapter, recognizing your families of functions. Now on these two, stop the video and copy them into your notes. Alright, so these graphs show symmetry with respect to, do you know how to answer that question? If you have already filled in x-axis, you are right. So on these, if I folded the graphs over the x-axis, the two halves would overlap each other. So if you take a look at it, guys, you might say, oh, so this point is the mirror image. Whoa, that's not where that meant. Sometimes you'll notice that this screen, I'll touch in one place, but the writing shows up in another. So sorry about that. So those two dark blue points are mirror images with respect to the x-axis. So 1, 2, 3, 4, 5. So it looks like that this one's at negative 5, 2, and this one's at negative 5, negative 2. And so on the second graph, I'll pick these two pink points and make them blue. So 1, 2, 1, 2, 3, 4, 5, 6. So this is 2, 6. And this is 2, negative 6. So if I'm going to have a graph that's symmetric with respect to the x-axis, I would say both xy and are on the graph. Do you know how to fill in that blank before I do? Because this is numerically, and this is going to have to do with how we algebraically test. This has for symmetry. So did you happen to fill in both xy and x negative y are on the graph? So on this one, guys, if you go to the right and up, you have to go to the right and down that much as well. Or if you go to the left and up, you also have to go to the left and down that much. Now, if these graphs are functions, what types of functions would they be? Did anybody say odd functions since I did even functions last time? I was trying to trick you and see if you were thinking, do either of these graphs pass the vertical line test? No. So these are never functions. If you get some symmetry with respect to the x-axis, you cannot be dealing with a function because the graph will never pass the vertical line test. All right. So let's look at another type of symmetry. Again, jot these down. Pause the video if you need to. You probably do need to. Put them in your notes. Alright, so these graphs, you may not recognize the type symmetry. This is a harder type symmetry, in my opinion. So this is called symmetry with respect to. Now, some people will go, well, it's with respect to both the x-axis and the y-axis or something like that. Not really. Like a circle could be symmetric with respect to both the x-axis and the y-axis, but these are symmetric with respect to the origin. So this is rotational symmetry. So if you could imagine, like on this first graph, if you could imagine that the origin was a hinge, and you could spin the graph around the hinge like you would spin like the spinner on a, what's the game where, Twister, like the spinner on a Twister board game, then the graph would, after you spun it around 180 degrees, it would overlap itself. So sometimes that's hard to see. If you were to trace from the origin outward, as your right hand traced out and up, your left hand would do the opposite. Your left hand would trace left and down. So if your right hand traces to the right and down, your left hand would trace to the left and up. So as you move away from the y-axis or the origin, your right and left hands are always going in opposite directions completely. So take a look at this. I'm going to look at this point, and if I were to spin the graph around 180 degrees, it would overlap the point in the third quadrant. So I've got 2, 1, 2, 3, 4, 5, 6, 7, 8. So this is 2, 8. This is -2, -8. Now, on this one, I would say this point, if I spun it around the graph around 180 degrees with the origin being my hinge, it would overlap the point that I've marked in the fourth quadrant. So this is 1, 2, 3, 4, 5, 6. This is negative 6, 2. And this is positive 6, negative 2. I hope you're seeing what the numerical pattern is. And again, we've got the same kind of thing going here. If I say, what about this point and this point? Well, let's see here. 1, 2, 3, 4, 5, 6. So this is 6, 3. So I know this is going to be negative 6, negative 3. Or again, you could label these 2 points. And this looks like, let's see here, 2, negative 2. So this is negative 2, positive 2. So can you fill in the blank? Both the points x, y, and are on the graph. If you said negative x, negative y, then you are correct. So if your right hand goes right x and up y, your left hand needs to go left x and down y. If your right hand goes right x and down y, your left hand's going to go left x and up y. So these can be functions, and if these are functions, they are odd functions. So I like to say, look, what you wind up with is a symmetry with respect to the origin. You have opposite y's whenever you have opposite x's, and you have odd functions.
Good morning out there in WRVL land.
So this is the O rule. So odd functions are symmetric with respect to the origin, and opposite x's produce opposite y's. Okay, so I don't know if you can hear the music that they just started in the background. I apologize for that. So on these, by the way, do you recognize that this is the first graph is a cubic function, which is a type of polynomial function? Now, the second graph here is a trig function. So I see that it is consistently up and down in a wave pattern. And then last but not least, this bottom graph is a rational function. Okay, so we've gotten the announcements and the music to stop. Let's talk about finding whether equations have symmetry. Now, guys, we're not talking about just plugging these in to the calculator and looking, because any schmo can do that. All right, what we're talking about is if we're trying to generate the graph by hand because we're unfamiliar with it, could we identify whether the graph has a type of symmetry in order to help us graph it by hand more quickly? So we are going to run an algebraic test. So when you see these problems on WebAssign, if it says algebraic test, there's a couple of different ways to do this, but the test that I want you to run is a T-chart test. So if you were to do one of these on the weekly quiz for me, you would write the equation down, you'd build the T-chart, and you give your answer, just like I'm fixing to show you. So on this, the algebraic test, well, I know that the thing seems to be what's happening when I plug in opposite x's. So I'm going to plug in some opposite x's, like -1 and +1. I'm going to see what happens. Now, if the y's you get have nothing to do with each other, you're not dealing with a graph that has symmetry. So if I plug in, I'm going to have -1 squared is 1 plus 1 is 2 on the bottom. So I get 1/2. When I plug in 1, I also get 1/2. So opposite x's are producing the same y. Well, I need to do one more pair of x's to make sure I have a trend and that this wasn't just a coincidence. So I can pick any x's I want. I can be like wild and crazy and pick 22 and negative 22, or you can keep your number small, which is normally what I do. But whether I square 4 or negative 4, 4 squared is 16, and 16 plus 1 is 17. So both of those give me 1/17. So think about it. I'm not going to do the whole graph, but I'm going left 1 and up a half, and right 1 and up a half. I'm going left 4 and up 1/17, and right 4 and up 1/17. So I'm building symmetry with respect to the y-axis. So symmetry with respect to y-axis. So that's when opposite x's produce identical y values. Now on the next one, the problem is that I don't have y isolated. So that's going to be the first thing, because when you build a t-chart, you typically isolate y first. So y squared equals negative 10 over x, and y equals plus or minus the square root of negative 10 over x. Now you might go, you can't have a negative under the radical. I most certainly can if I pick good x's. So for instance, if I were to pick 1 and negative 1, then plugging in 1 would make me do plus or minus the square root of negative 10. The square root of negative 10 is non-real. Well, so that means 1 is not in the domain of this function. So well, that means, guys, right off the bat, that I cannot have symmetry with respect to the y-axis or the origin, because I'm getting an issue. Now, if I plug in negative 1, then I get plus or minus the square root of negative 10 over negative 1 is plus or minus the square root of positive 10. Now, see, I do have x's I can plug in, but look, on this situation, when I plug in negative 1, I plot the square root of 10 and negative square root of 10. Do you see where I'm going with this? If I plug in 2, again, I get plus or minus the square root of negative 5, which is non-real. But when I plug in negative 2, I get plus or minus the square root of positive 5. So again, when I plug in negative 2, I plot plus or minus the square root of negative 5. So I can see by the way the points are lining up that this graph is going to have symmetry with respect to the x-axis. Okay? So if you plug in some x's and get non-real answers, symmetry with respect to the y-axis and the origin are out. It's not going to happen. So on this next one, I'm going to isolate y again, so I can start with 4 over x. Now I'm going to plug in 1 and negative 1. So when I plug in 1, y is 4. When I plug in negative 1, y is negative 4. So there's a pattern in my y's. Do another pair. So remember, you need to do 2 pairs of opposites in order to establish a trend. And that will complete your work for the algebraic test. So when I plug in 2, for instance, I get 2 for y. When I plug in negative 2 for x, I get negative 2 for y. So think about it. In this case, I plugged in 1 and got 4, and plugged in negative 1 and got, sorry about that. I plugged in negative 1 and got negative 4. When I plugged in 2, I got 2. And when I plugged in negative 2, I got negative 2. Guys, that's going to be symmetry with respect to the origin, because opposite x's gave opposite y's. That's my rule. All right, so on the next one, it's already isolated y, so I'm going to go ahead and plug in 1 and negative 1. So when I plug in 1, 1 minus 1 is 0 squared, which is 0, plus 2 is 2. And when I plug in -1, -1 minus 1 is -2, squared is 4, plus 2 is 6. Oh, hold the presses. I don't need to do any more work. If you find any pair of opposite x's that produces y's that are unrelated, this is telling you that it's not showing, I'll say no symmetry, but to be more specific, more precise, it's really that it's not showing symmetry of any type that we're talking about. So there's no symmetry with respect to the x-axis, the y-axis, or the origin. Now, hopefully you recognize that the graph that we're dealing with here is a right side up parabola, and the x minus 1 tells you to go right 1, and the plus 2 tells you to go up 2. And then the a value is 1, so it would be out 1, up 1 from the vertex. So there is the graph of my parabola, and you know that parabolas are symmetric with respect to their axis of symmetry. So saying no symmetry just means no symmetry that we're talking about at the moment. So I wanted to be precise, although in your homework, if you say no symmetry, hey, that is a-okay. The last type of symmetry question I could ask you about is drawing symmetry. These are kind of fun, and most of you all will have a good instincts for this. So if I ask you, can you add to the graph in order to make it symmetric with respect to the origin? I'm going to do that one in purple, so I'll superimpose them both on the same graph. Origin's a little harder in my opinion, but I'm going to say, well, this first point right here is 1, 2, 3, 2. So I'm going to go right 3, up 2. So that means I need to go left 3, down 2. And then I want to try to invert my shape a little bit. Now this next point on the graph is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Whoops. 1, 2, 3, 4, 5, 6, 7. So right 5 up 7, so I need to go left 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, 6, 7. There we go. And again, sometimes this screen picks up writing that I'm not actually doing. I'm not touching the screen, so sorry about that. Now this point looks like it's 7 over, so 1, 2, 3, 4, 5, 6, 7 to the left. And it's always easier when it's straight lines to produce that graph. And then I'm going to go to 8, -3. So that means I need to go left 8, up 1, 2, 3. And it looks like I need to kind of make it this shape. And then, yay, I just go right 2. So I'm going to go left 2. And that graph would be symmetric with respect to the origin. So trace it with your fingers from the origin outward. Are your right and your left hands always moving in opposite directions? Now, I bet you're like me and you think that doing the symmetry with respect to the y-axis is easier. So on that one, the first point, that 3, 2 will be -3, +2. So to me, this one's a whole lot easier. And then this point, I think we said was 5, 7. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So I'm going to go out 5, up 7 on both ends. This one, it was just, I think, out 7. So out 7, well, there we go. Again, every now and then, I get stray marks because the computer just does weird things. So this point was out 8, down 3. So I need to go out 8, down 3, but in the opposite direction. And then I need to go left 2 from there. So those are the symmetry questions that we're going to work with. We'll pick up with calculator work on the next little video.